Please welcome Daniel Leech.
Hello. So I'm going to start my stopwatch. I've just done that, so I'm not going to speak for too long, and I've got to remember to speak into the microphone. So I have a company. It's called DTL Soft. I'm the only employee in this company. I do programming. I've done programming for maybe 20 years. Maybe that's a slight exaggeration. But I've mainly done PHP, and I maintain two projects. One's called Factor, which is a language server. Don't know if anybody uses it. Okay. I'm sorry about that. And PHP Bench, which is a performance profiling tool. It's like PHP Unit, but for performance. And about 500 things that I've just started and just abandoned. So I like running. It makes me happy. Today I'm going to talk to you about value objects. And why am I giving this talk? So I'm giving this talk because I wrote a blog post. And I wrote the blog post because I've been sitting in a meeting and people are discussing if they should implement value objects in their projects. And if they implement the value objects, which interfaces should they use? Which abstract classes should they extend? And which libraries should they pull in from Composer in order to use value objects? So I'm kind of sitting there and I'm like, oh, come on, I'm already using value objects in your project and it didn't need any of these things, right? In fact, I'd find it difficult to work without using value objects. So for me, value objects are a way of modeling your code. And modeling is a way to describe and represent the problems that you had when you're coding, when you're programming. And there are lots of tools that we can use in our modeling toolbox. It's a bit analogous to a model train set or something like that. You need lots of tools to build these things. And I like to think of it as maybe Michelangelo did when he looked at this block of marble. So you've got this big block of marble, and he's looking at it, and he's and he starts chipping away. It says, "Oh, Michelangelo, what are you doing?" He says, "Oh, I'm chipping away at this." "What? Yeah, but why?" "Because I think there's a cat inside, and it wants to get out." And he's chipping away, and he says, "If I just chip away the excess marble, I'll be able to see the form within the marble. The form's already there. All I have to do is expose it." And I think this is similar to what we do in programming. When we're presented with a problem, so you get a Jira ticket, and you read it, and it's a problem statement, and it says you've got to solve this problem. And at the beginning, it's not clear. You can't see the contours of the problem. You can't see the components of the problem. You can't see the way the components interact. And maybe you've solved this problem dozens of times before, but even then, the particular solution, the ideal solution, is going to vary by the business, and it's going to vary by the constraints that you have at that time. So the way we identify these problems, we represent this problem by chipping away at this marble, and in our case, that's building a model to represent the problem. So value objects are one of the tools that we can use to do that. And they're probably my favorite tool. So, yeah. So what are value objects? So obviously, objects of objects, but value objects are objects that represent a value. So that just begs the question of what is a value, right? So values are things that have no identity other than themselves. 7 is a value, but 8 is a different value, right? 7 is a value, 8 is a value. You can't update 7 to be 8. 7 exists, right? We can't update it, but 8 is another one. What about an IP address? So this is a location on a network. If we change any of the attributes in this IP address, it becomes a different IP address. It becomes a different location on the network. It becomes a different value. So the identity of a value object is the sum of its path. You can't change any individual attribute without changing its value. And that's what it looks like. So that is the MVP value object. You can argue if you should model an integer, because we've already got that in PHP, right? It's an int. But that's it. That's, you've succeeded. You've created a value object. Congratulations. Were there any questions? So, so you've probably seen value objects in your code. So a date, right? Now you probably used a date time or date time immutable. So you're probably wondering why I haven't used the date time here. And the reason is that date time actually comes with a lot of behavior, a lot of complicated behavior, which may not be necessary to solve your problem. So if all you need in your problem space is a representation of a day in the year, then just having a very simple object to represent that is going to be a lot more stable than having date time with all the time zones and all these complications that could potentially cause bugs in your application, right? So a lot of modeling, it's reducing, identifying the necessary complexity for your projects. Like money. Like we can't talk about money without talking about currency. We can't say a car costs 20,000 and, a computer costs 1 million, because it makes no sense without a currency. So rather than passing these two things around separately, you can represent their dependency on each other by putting them in an object. So you've probably seen a money object and a geolocation, so a particular point on the Earth, and a color. And we'll be looking at colors a bit later. What about an order? So an order, so who's worked in e-commerce, right? Everybody's, like quite a few people. So you've probably got an order entity of some kind. And entities have IDs. So this is actually a UUID. This is the identifier. And that is a value object. And it has a state. And if we change any one of these things, it's still the same order. A value object will change if we change any of its attributes, but it will change its identity if we change any of its attributes. With the order, as the order is placed, it's shipped, it's returned, these things can all change, but it remains the same order because it's identified not by the sum of its parts, but by its identifier, and everything else can change. So let's have a look at what makes a good value object. So this is the MVP. So you were passing around red, green, and blue as separate parameters, separate variables, and you refactored to just have an object. And this is good. This is already 10 times better than passing around the three variables independently. But the first thing we can do is make it immutable. So why do we do this? So as I said at the beginning, you can't update a value to have a different value because that doesn't make any sense. If you took the number 7, and I don't know, say you've got 7 cars, and you updated the number 7 to have the value of 8, then you've changed the universe, right? It just breaks the laws of physics. It doesn't make any sense. In the same way, you can't update, you shouldn't be able to update a value object because you actually have kind of the same problem. Like you could have many references to that value object in your code, and if you were to change the value, then it would change it globally, right? It's one of the risks of having references to things in code. So always make it immutable. If you need to mutate it, if you need to perform operations on it, you always return a new instance of the value object. So it should be immutable. It should also be final, but I think it should be final, right? Nobody should not use final, so that's fine. Why would you want to extend a value object? So another thing you can do is actually validate the value. So this is quite an interesting thing. So if you're in your code, you're in a function, and you get a value object coming in, you don't have to validate it, right? It's not your responsibility anymore. If you're passing in 3 parameters, you won't be sure that those individual integers, those strings, or whatever they happen to be, are going to be valid. So you might have to revalidate it in several places. With a value object, it's not your responsibility. It's not that function's responsibility. It's the responsibility of the object itself. If you can instantiate a value object, you should assume that it's valid, because all value objects should validate themselves so that they represent so that they are a valid representation of the value that they represent. We also see static constructors. So who uses static constructors? Right. So here we've changed the constructor to private, and we've added a public static function, and we say from RGB. So this is a color. This is a range of 0 to 255, 0 to 255, 0 to 255. So why would we do this? So one advantage is that we actually hide the internal representation of the color. This means, because this is private and this is just an arbitrary constructor, there's nothing there to indicate. So if we have this one, we say new color 10, 100, 20, we can already guess that internally that's represented as RGB, but it doesn't have to be. So by adding a static constructor, we hide that implementation. That might not be so important, but it does allow you to refactor the internal representation should you want to. It's kind of an incidental benefit. But the real power comes when we add different constructors, right? So we can add from HSV, from int, from hex. And as a side effect of that, you can just go color, colon, colon, and see all the ways that you can, all the representations from which you can create this abstract concept of a color. And we can go the other way. So we can go to RGB. So in that, the value object actually becomes this kind of pivot, right? So you can go to the value object, you can go from, you can go from the value object, you can go to back to a different representation. So you use it to convert the representations, which is surprisingly useful. And a lot of these patterns do become surprisingly useful. Like, you don't anticipate how useful they are until they sort of reveal, and you're chipping away and another block of the marble falls off. So yeah, 2 RGB, 2 HSV, 2 color name, whatever. And you can aggregate value objects within other value objects. So if we have a byte offset range, so we have a byte offset, which is, I don't know, 2, and then a byte offset that's 5, we can put them in a range. Why would do this? Because we're talking about a range from here to here, and then you can add behaviors on that range while still benefiting from the underlying, like, individual atoms, if you like, of these byte offsets. So combining value objects to build bigger value objects, which is quite cool. So, not sure what's going on there. Code smells. So most people are familiar with code smells. They're things you look in your code and you think, that stinks a little bit, doesn't it? And it normally means you can clean it up. And value objects are a great way. They're easy to spot where you can use them, and they're great and usually very safe refactoring that you can perform. So if you have, like, make payment, we've got the amount in the code. So of course, this is a value object tool, so we make them into the money thing. But why? What's wrong with this? So we've already said it's, yeah, they depend on each other, but why is that important? So if you've got a controller and the user's making a post request, and they post the amount that they want to pay and the currency they want to pay in, and you as a developer pick those two things out of the request and assign them to variables, and you're not a very good developer, so you've got like a 1,000 line action in your controller, and these two variables have to make a perilous journey all the way down to this thing. And along that journey, they can get, like, the code could get hijacked because you've also got discount code, right? So instead of amount, 100 USD, you end up buying 100 discount codes. This is quite a common error, right? When, especially in legacy spaghetti code, when one variable gets hijacked with a value that it should never have had. And by having a value object, you lock in those two things at the very start, and you protect them. Okay, let's have a look at one more example. This is color interpolation. So basically, we've got a color on the left, and we've got a color on the right, and we want to return a color at some point between those two colors. So here we are. We've got the color utils class. Who's ever created a utility class? Right, you have all these static functions. Right, it's shameful, isn't it? So of course we go from R1, G1, B1, R2, G2, B2. Of course we do the color, the color value object, and it's much better, and we can walk away, we can feel a bit happier with ourselves. But we should always ask, can we go further? So we've already mentioned that it was a color range, and we saw the byte offset range, so we can make it a range. And again, we can walk away and say, oh, I'm pretty happy with that. That's much better. That's much more expressive. We've gone from 7 to 2. But again, can we go further? What does this look like? So now we've got a color range. We've got a subject. And we're operating, the interpolate function is operating on this subject, and it has an argument. What does that look like? So what if we move the color range before interpolate? So then we get the color range, and we've got a function we move the function to the color range value object. And suddenly, we don't need the color utils class anymore. Right? We can delete this function, and we found where this function should live. So when we create these util classes, these helper classes, we don't feel good about it. It's a necessary evil. We need somewhere to put this functionality, but we just don't know where it lives. And again, this is iterating on the model, and we didn't start off with this intention in mind. We didn't say, oh, we're going to get rid of the color utils class. It's one of these things when you're chipping away at that marble, and just this huge chunk just falls off, and think, ah, there it is. So only by iterating and getting deeper and going further do we sort of reveal what's going on in our model. We're revealing the contours of the problem. So operators. So an operator, this is an expression. Those are operands. That is an operator. It's an addition, division, concatenation. And in PHP, we've got equality. This will work out of the box with value objects because PHP compares values of the attributes in objects. So you can compare any object with any other object. If it has the same attributes, i.e. properties, then this will return true. And because value objects their identity is the sum, is the sum of their parts, this will just work. What about this? So we've got a greater than. Now you can't do this in PHP because we don't have operator overloading, at least not in userland. But even if you did, would it make any sense? So to say red's greater than red. Sorry. To say that red is greater than red, in what respect is it greater than red? Is it brighter than red? Is it redder than red? Is it more popular than red? You know, great, this isn't very descriptive. This isn't very domain specific. And the same with multiplication. If we could do this, would it make any sense to do so? So instead of, we can't rely on operators anyway, but we can add methods, operator methods, you might say. So we can say red is equals to red. And this might not be true all the time on all value objects. Or at least they might compare themselves differently, right? Maybe there's a different word to compare the equality of two different values. But more importantly, for in this instance, we've got the kind of domain of colors, the language of colors, and we could say red is brighter than red. Red is darker than red, or whatever. We can mix one color with another color and get a new color. So we can have a much richer representation of, a much richer model of the problems we're trying to solve. Okay. So, yeah, bad practice. So these are kind of anti-patterns that I've seen over the years, and often things I've actually done myself, right? So the first one is, and this isn't just about value objects, this is ever, right? Never do this. So what I've done here is I have created my static constructor, and I'm saying new self, and then I'm just higgledy-piggledy. I'm assigning red, green, and blue. And you can see they're private. And in PHP, we can do this. I didn't realize you could do this like 10 years ago. And when I discovered that you could kind of just bypass this visibility if you're in the same class, blew my mind. I thought, I want to do that all the time. This is fantastic. And I thought it gave me a lot of flexibility, but actually it just tied me in knots. And for the simple fact that you're adding, every time you do this, you're adding boilerplate. So you have a responsibility. Every time you add a static constructor, you have this responsibility to validate it. And because, we're not deterministic people, we will often forget that. This is how bugs, this is how developers introduce bugs. We might forget to assign one of these properties after converting it to hex or whatever. So this is boilerplate, and the thing about boilerplate is that boilerplate is technical debt. And every time you implement some boilerplate, you're scaling your technical debt, you're adding to your technical debt. So we should aim to not have technical debt, right? And in this case, it's very simple, it's very powerful. You just have a rule in your head which says always, always use the constructor. It's there. It's awesome. It is the place where the dependencies for the class go in. They get loaded in the top, and that's it, right? That's how the dependencies get there. They don't get loaded from the side. They don't get loaded with reflection. They get loaded with the constructor. And by doing this, that means you have a single point of entry, and you can validate it. So always inject via the constructor because it's your guard. It's a thou shalt not pass against invalid state, against having an invalid value. Do not, so maybe controversial, do not extend abstract classes, do not implement interfaces. I've seen people creating like value object interfaces because, I don't know, all value objects should have an equals method, right? All value objects should have a greater than, a less than, or a bunch of characters. But we've already seen that this doesn't make sense in some cases. You're putting, by having this value object that everything implements, you're putting this constraint that all values have to abide by these rules. What if you have values which cannot be compared, or at least they can't be compared with equal? You might have greater than, then you might be throwing, not implemented exception, and that's not very safe. More importantly, if you have a function with two parameters and they're both value object parameters, what does that mean? Like you get a value, you get a house value object, you get a giraffe value object, and then you ask, is the house greater than the giraffe? Is the giraffe equal to the house? It doesn't make any sense. You don't need to implement this interface. By doing this, you reduce the value, you reduce the expressiveness of your domain, of your model. So they're not an abstract type. So this is going to be a tricky one. It is a tricky one because a lot of frameworks will start off and they'll suggest that you create an SRC folder or an app folder in Laravel, and then you put in an entity form value object namespace, and you put everything in those things. And this is how legacy code starts, right? This is how you start a legacy code base. But at the beginning, it looks fine. It's fine. But over time, you'll just start accumulating stuff that is incoherent, that doesn't belong with each other. So we have this value object namespace. We might have, some charts, entities, I don't know. Maybe we've got some other things relating to colors somewhere else in the code base. And then we've got a value object like color gradients, which happens to be a collection. Should that go in a collection namespace, or is it's a collection of value objects, and then you have these weird conversations with your colleagues? And then you have invoice number, license plate. What are they doing there? So it's much better to start projects by dividing by domain, right? In domain-driven design, this will be a bounded context, and it just allows you to have the space. If you're starting a new feature tomorrow, you create, this namespace, or you're creating a library. You just put everything in there, and you've got space to solve your problem. You don't have to worry about the license plates or the UUIDs being in there, because they have nothing to do with the charts, right? You're giving yourself the space to solve new problems. And you can't do that if everything's spaghetti. Do not use a value object suffix. So it might go without saying, but Yeah, I mean, what would you rather work with as an API? Would you rather do that or that? I mean, this would really, it would hurt my eyes if I had to look at that all the time. And you should be using, these are part of your language. You've got to, you're reciting this stuff to yourself as you're reading your code. So, just be succinct. Don't add unnecessary suffixes. So value objects are the value. We don't need to repeat that fact. So again, you can question whether you should have from array and to array on a value object, but at least in the case of DTOs and other things, people do this quite a lot. So from array to array, and what's wrong with this, right? A lot of people do it, and it's fine and it's fast. For me, the problem is that you can either not have this boilerplate of validating that things exist and the validating that the types are, and risk having undefined index errors that are not very descriptive, right? That don't really help you solve your problem. Or you can add lots of validation to ensure that the incoming unstructured data has the keys that you can pluck out of that unstructured data and inject into your constructor and be confident that it's not going to crash. And while also having a to array, and remember that to array you should be able to feed to array back into from array, right? They should be the same. They should produce the same structures. By doing this manually, again, it's the boilerplate, it's the technical that every time you do this manually, you're introducing a lot of places in your code where you can introduce bugs. So mapping is a hard problem, and there are libraries to do that. And increasingly, there's very good libraries like Valinor, which do that, and they can actually be pretty fast. Although at least I think they'll be pretty fast soon, if they're not quite there yet. And I've got some links at the end of the presentation if you want to read more about mapping. Yeah. So mocking, who likes mocking? Right? Who's a mocking person? That's fine. Who doesn't like mocking? Okay, so it's about 50-50, and that's fine, right? There's two different ways to approach testing. But one thing either school can agree on is that you should not mock value objects. It makes no sense. This is pure data. Create mock. We do mocking in this project, so you should mock this value object. Why? It has no dependencies. It has no side effects. It has pure functions. It will never change. Yeah, don't do that. Don't make your life more miserable than it needs to be. Nobody wants you to do that. Okay. So, coming towards the end. So, value objects should be immutable. Thou shalt not change, but thou mayest spawn new versions of thyself. They should be correct. Thou shalt not bear false representation. So they should always fit within the bounds of the values that they represent. They should be isolated. They should not associate with false prophets. So no third-party libraries, no weird interfaces, right? And be functionally pure. So I didn't talk about this as much, but yeah, it comes back to not having any side effects. If you call a method on a value object, it should not call a service in the container. It should not mutate global state. It should not change the system clock. It should not drop the database, right? They're very simple, isolated objects. But yeah, but don't listen to me, right? Everything in this talk, as with in all talks, I guess, are the heuristics. There's things that we've done and which we find to be useful, but it's not to say that you should always obey them blindly, right? Any solution, yeah, you can call an object a value object if it makes you happy, but it might fall short of some criteria that technically would make it a value object, or you might find an object that's kind of striving between two different patterns, and it doesn't matter. The most important thing is you create a model that works, that represents your problem, right? And the most important thing is that you solve your problem. And you shouldn't be afraid to try new things and learn from them. If bypassing the constructor works for you, then go for it. I'm sure at some point you'll find out that it's not a very good idea, but that shouldn't stop you from trying. And value objects are just easy, right? You don't need dependencies. You can just create a new value object in seconds. You don't even need to validate it. You don't need to make it final. You don't need to make it immutable. You don't need to do any of these things just to get a lot of value from just using an object. So that's my talk, and it's exactly 30 minutes. That's good, isn't it? If you scan this slide, there's blog posts, including the one that I wrote about value objects, and also the link to rate this talk, should you wish to do so. Yeah, and thank you.
Thank you very much, Dan. So we got a question, although somebody was writing. Oh, maybe it's just come in. All right, 2 questions.
Okay.
If a value object fails validation on construction, would you recommend throwing domain-specific exceptions?
Yeah. Why not? I mean, it depends. I mean, it always depends, right?
You just gave the antithesis on one.
In general, it is in your domain, and a domain-specific exception is more meaningful if you're going to catch it. Personally, if I'm throwing something, I'm never going to catch it. I just make it a runtime exception. But yeah, it depends. You absolutely can and should throw a domain exception, as you know, if it makes sense and if it's part of your problem solving, right? So why not? Yeah.
PHP version, why not?
Really?
Yeah, older versions of PHP, you could throw an exception in the constructor. It would kill PHP.
Okay, I didn't know that. Yeah.
So if you're using 7 or above, then you should be fine. But if you're having to deal with legacy applications, you will have that problem of throwing an exception within a constructor.
Okay, I wasn't aware of that. I thought that was within toString, actually. You couldn't throw an exception into string.
It's the same with the constructor because it's anything with the double underscore.
Okay, well, I've learned something new.
This is where the static constructors
Sage.
you can still use the same language, but you then put the exception check in your static constructor.
Okay.
Because that is something or a magic one.
Okay, I'll have to check that because that's not what I said in the talk. So.
If you're on the older PHP and
Yeah.
you can kind of do it because you can't, then it's the trade-off, like Gary said,
Yeah.
trading off because you're heading into that level.
Okay. Yeah. Thanks.
All right. What's the best way to avoid repeating myself if I need similar value objects in more than one place, e.g. colors in charts, but also colors somewhere else?
I mean, in that case, if it's the same color, because depending on the problem you're solving, you know, the concept of color could be different, or you might have different methods that you need to add on these value objects. You might be solving a subtly different problem. If you are solving the exact same problem, then it's really a case of pulling that out into a shared space, like an agnostic space between those 2 domains, right? That you can share between them. I mean, there's no other way to do it. That makes sense.
Yep. One last question, and then we can go for lunch. Should I integrate dependencies for validating attributes in value objects, or abstract that to another service?
That's a good question. So I wouldn't use a validator to validate value objects. So I'd typically just do that with assertions and runtime exceptions, and the user validation would happen within the controller, for example, on the DTO, which you'd annotate or you'd map with YAML or whatever you do. But the user validation would be mapping to this DTO, right? Only after that would it map to like the value objects once the input's been validated, if that makes sense. But yeah, again, heuristics, right?
Makes sense. Okay. Please give Dan another round of applause.